Hi, I'm Alfonso Lagares, and this is my Physics 2212 Lab 3 report, where I will be studying the magnetic field of a bar magnet.
First, I'll introduce the lab, its goals, and the fundamental principles involved in it. I will then discuss the data collection and measurements taken during this lab. The result of the lab will be interpreted and presented through a glow script model. And finally, there will be a conclusion and a couple of questions.
This lab's goals are to understand magnetic fields, to find the relationship between distance and magnitude of a magnetic field, and to use fundamental principles to compare magnetic measurements. To do this, we'll be using Biot-Sabat's law as well as the equations for the magnetic field of a bar magnet. The relevant experimental values found during this lab were N, which came out to be negative 2.681 meters, and the magnetic dipole of the bar magnet, which came out to be 1.16 amperes per meter square. The procedure for this lab first starts with determining the direction of the magnetic north, which can be done by rotating a phone's magnetometer until the x component reads 0. A meter stick was then set up perpendicularly from this direction. The meter stick was then used to locate the magnetometer sensor on the phone by sliding the phone up and down and marking the axes with pieces of tape. The phone was finally moved some known distance from the bar magnet, and the magnetometer readings were collected into the provided spreadsheet. The data collected through the lab's procedure yielded the presented results. As it can be seen on the logarithmic plot, the resulting value for the slope of the linear fit comes out to be negative 2.68, giving the experimental portion of this lab a 13.3 relative percentage error. The data collected from this lab led to some important interpretation questions. First of all, when the magnetometer was far away from the magnet, it measured a near zero x component for the magnetic field, as the dominant field was the one caused by the magnetic north pole. The magnetic field magnitude increases as the magnetometer got closer to the bar magnet, which shows that the magnitude is inversely proportional to the distance of the source. The position of the magnetometer had a big effect on the measurement component of the magnetic field, as the small variations in the relative positioning of the magnetometer inside the phone were significant enough to change the collected data. The results of this lab were modeled using GlowScript, a Python framework. Some assumptions were made to describe the physical phenomena. The bar magnet was assumed to be a perfect magnetic dipole, and its behavior was modeled using the function for such a theoretical model. The magnetic field around the bar magnet was then plotted, which shows that the direction of the magnetic field is consistent with the experimental values. Finally, the magnitude of the magnetic field was measured at a point 45 degrees from the bar magnet, which was measured to be 2.68 times 10 to the negative 5. Finally, if the experiment hadn't been oriented to compensate for the magnetic north, all readings would have been skewed in the directions of the magnetic north. We would also have seen a general loss of accuracy for all the values measured during the experiment. If we had stuck two identical magnets together end to end, the direction of the magnetic field would have been the same, but the magnitude would have been around double, given that the distance between the two bar magnets was small enough.